All right, you get a copy of your notes when this is over. You remember what that is? That is the formula with slope and y-intercept for graphing a line. Different equations cause different shapes. Today we're going to make a parabola. This is a parabola. Okay? Or this. According to the equation, you will be able to tell if it should go up or if it should go down. All right. Do you remember this?
Yeah, that's what we're doing right now.
This is the formula for an equation that causes a parabola. So if you're graphing this and you don't get a parabola, something's wrong. Now, a cannot be 0. Think about why a can't be 0. If a was 0, the leading coefficient, then x squared would disappear and it would be a line. So a can't be 0. Okay, what else do I want to tell you? Okay, let's just do an equation. Y equals negative 2x squared plus 3x plus 7. It is very important that you can pick out the A, the B, and the C, because you're going to need it. So what's A here? Negative 2. What's B?
3.
And C?
7.
All right. See, it's hard for me because I don't know what you know. So, a parabola is going to be caused by that equation, which is called a quadratic function. You had linear functions earlier in the year. Now you have a quadratic function, okay? So, do you remember when you had a linear function, there was a pattern, like say this was 1, 2, 3, and this was 5, 10, 15. You remember all that? You've had that. All right. Let's just put this up here. So, on a linear equation, the x value has a constant difference, and the y value had a constant difference. Plus 5 on one side, plus 2 on the other. But it's the same. So in other words, if I had 1, 2, 4, and then 5, 10, 15, that's not a line. Right. Because there's the 3 missing here. The 3 would be with the 15. Now in a quadratic function, which is y equals ax squared plus bx plus c. In a quadratic function, let me give you an example of how you can tell if it's a quadratic function. Negative 2, negative 1, 0, 1, 2. Same pattern, same difference. Now, in a quadratic function, 8, 2, 0, 2, 8, down 6, down 2, up 2, it's not the same, right? But look at the second difference. What happens from here to here? Minus 6. What happens from here to here? Minus 2.
I didn't see, wait.
Minus 2. What happens from here to here?
Plus 2.
Plus 2. Plus 6. Now let's look at the next difference. What happens from negative 6 to negative 2? Plus 4. From negative 2 to 2? Plus 4. From 2 to 6. That's how you tell if a table of values is a quadratic function. The second difference is the same. Yes?
Why'd you put 820, 828?
Because this is some random equation where I plugged in the x, and that's what I got for the y. Okay? I didn't give you the equation because we're not there yet. Okay. the vertex. Anybody know what a vertex is? On a parabola, the vertex, in this case, is the highest point. It is also in the middle. And it has an axis of symmetry. In other words, if I folded this parabola on this line, it would be exactly the same on the other side. Okay? It also has a vertex that could be the least value. Highest value, least value. Stop me if you're not with me ever. The lowest value, well, I'll show you. So here's a parabola that was graphed by y equals x squared plus 6x plus 9. If my vertex, let's say it's on the axis right here at -3, 0. -3, 0 is the vertex. It has a minimum value, in other words, doesn't go below that, of 0. Your y tells you what the minimum is. If I moved it up 1, it would be, let's just do it. Let's say I moved it up 1. And this would be, let's say, -4, 1. The minimum value is 1. Don't get mixed up with x and y. The y tells you the minimum value. And your vertex in this case is -4, 1. Now, this has an axis of symmetry at -4. In other words, -4 is where it cuts it exactly in half. By the way, if you ever miss class, you have got to get online and watch the video. Everybody needs to check their email when they're absent. I'm going to send, if I figure out how to get on YouTube, I think I will, I'm going to send you the link to the lesson. Okay? And then you can email me for the worksheet if you want to do it ahead of time. It will help you to do everything if you're not too sick before you come back. All right, so let's take one where we have a parabola that looks upside down. Now it has a maximum value of whatever that y is. So let's say this is 3, 5. Okay? The maximum value is 5. The vertex is 3, 5. The axis of symmetry is 3. Now, when you write the axis of symmetry, you always put x equals 3. Okay? With me? Nothing hard yet? I'm going to get you through quadratics. You just hang in there. Everything you've learned all year is all going to come together in this chapter. And why you learned it and why we have equations. And, we're going to do story problems where, you might shoot a basket up in the air. We're going to know when it lands. All kinds of fun stuff. I know you don't like story problems, but they won't be hard, I promise. Y equals ax squared plus bx plus c. You will also notice that if a is positive, your parabola looks like that. If a is negative, your parabola will look like that. Always remember that, so when you're graphing it, you know you're getting the right parabola. Yes?
Would we have to distribute the negative?
No, you're not going to have to do anything like that yet. No. And how would you distribute that anyway? There's no parentheses. Now, the biggest thing that kids cannot do is if x squared, say, is -3. Let's just see. ax squared. X equals -3. A equals 2. What is that value? How much?
18.
18. X squared is always positive because positive times positive is positive, negative times negative is positive. When you are going to plug it into your calculator, you are going to, because these numbers will get hard, you're going to plug in 2, left parenthesis. You ask, why is there a parenthesis? Because x squared has to be done first. 2, now you can do a lot of these in your head. You won't have to plug it in the calculator. But this is how you're going to use your calculator. It's going to be 2, left parenthesis, negative 3, right parenthesis, caret 2. That caret will take it to whatever exponent you have. And if you have a calculator, you might try it. You should get 2, left parenthesis, negative 3, right parenthesis, caret 2, and you should get 18. Try it. Where's your calculator?
I left it at home.
But you got one? Okay. Excellent. Where's your everybody got one?
Yeah.
All right.
I do.
You gonna get one?
Yeah.
When? Do you understand when these are decimals and things, you're not gonna survive. Okay? Gave you a week's notice, man. You get 18? Okay. Everybody knows how to use their yes.
Mine says error.
If it says error, you punched it in wrong. But let's see what you did. Okay, clear. What'd she do wrong, Zim? Oh, did you use a subtraction sign for negative?
Yeah.
There's the problem. On the bottom is your negative sign. Never use the subtraction sign because now it thinks that you're subtracting 3 inside a parenthesis, which makes no sense to the calculator. Syntax error is your error, okay? Always use the negative sign, never use the subtraction sign for negatives. So, summary. A quadratic function makes a parabola, and I have this on your notes. It can be written as y equals ax squared plus bx plus c. A can't be 0, because that would eliminate the x squared and you'd have a linear function. And the x on the t-chart has a second constant difference that's the same. So far, so good? Let's graph. Let's have I got one here, I think. Yes. Y equals the function x squared plus 2. Now there's no x, but that's okay. As long as it has x squared as the highest exponent, it's going to be a quadratic function. Now if it has x cubed, that's a whole different equation. The highest exponent is 2. Now, I'm going to have you, until you learn how to graph it the short way, I'm going to have you pick 5 points. -2, -1, 0, 1, 2. That's just a good place to start. And we're going to plug in -2, -1, 0, 1, 2, and get our y value. So can anybody tell me what y is going to be here? Anybody? 6. -1, 3, 0, 2, 1, and 2, 6. So let's graph it. I hate this graph. These numbers are confusing. -2, 6, -1, 3, 0, 2, 1, 3, 2, 6. Now, what you're going to have to be careful of is it's never going to look like that. That's from an absolute value. if I plugged in negative 1.5, negative 1.1, 2, you know, all these constant little fractions, you would see the curve. And so it's going to curve, so make sure you make it curve. And it'll look, that's not even that great. It's going to curve, okay? Also, when you are graphing, make sure you have enough points. Let's say, and you can pick anything you want for x. I'm just telling you, it's easy to start with negative 2, negative 1, 0, 1, 2. You can put any numbers you want. But let's say you get a point here, a point here, and a point here, and just pick some random point that's up higher so that you know that your parabola doesn't necessarily go like that. If you have points here, you know your parabola, where it's going. All right, so don't be lazy. That's why we can't just have 3 points. You don't know how wide the parabola is until you get some points up here. Okay? Now, back to this. The vertex is 0, 2. Is that a minimum or a maximum? It's a minimum of 2. You can just write min of 2. All right? The axis of symmetry, x equals 0. That's the whole lesson. Just those things. Let's graph another one. Try not to give you too much at once on the day of a test. All right, let's graph y equals negative 3x squared plus 1. Okay, you make a t-chart. They call them t-charts? Okay. Negative 2, negative 1, 0, 1, 2. So who can tell me what you get if you put in a negative 2? I suggest you take the x squared first, multiply it by negative 1, add 1. And if you want to practice this on your calculator for when these numbers get hard, go ahead. It would be negative 3, left parenthesis, negative 2, right parenthesis, caret 2. Yes?
Would it be negative 12?
It would be negative 11, isn't it?
Yeah.
Negative 11. Now you're just off by 1, but that'll matter. All right, and you would know, because when you put that one in, that you probably wouldn't get 12 twice. Okay, what's negative 1 give me?
Negative 2.
Negative 2. 0? 1? 1?
2. No.
You guys, you're going to get, if you choose a 1, you're going to get a negative 2. If you choose negative 1, you're going to get negative 2. What you can do is do all the positive ones first, then you don't have to mess with the negative, and just mirror what you got. Because it's got to be the same, because x squared, whether it's negative 1 or 1, gives you the exact same answer. Okay, let's graph it. Negative 2. Now, I know that my parabola is going to have a maximum, and it's going to be upside down because of that negative 3. Okay, if you know those things, then you don't mess up. If you do something wrong here, you'll know it. Yes?
Wait, why is it a maximum? Because it's negative 3.
Okay, I'll show you. Okay, so negative 2, 11. Negative 2, negative 1, negative 2. That's 3. God, I hate this chart. 0, 1.
Wait, you missed
I messed up.
Yeah.
Negative 11. Negative 2, negative 11. And see, I knew right away. When I was putting these points in, I said, oh, this one's not going to be upside down. Something's wrong. Okay? So negative 2, negative 11, negative 1, negative 2, 0, 1, 1, negative 2. By the way, once you have those 3 points, you can use the axis of symmetry to mirror it. You really don't even have to work the other side out. So, and then we have See, this is 2 away from the y-axis, so I can go 2 away from it. I don't really have to graph it. All right, and then this parabola is a skinny parabola. All right, you had a question. I know it's going to be a maximum because the y tells me, is it the lowest or the highest point? The highest point, because you don't know the lowest, it goes on forever and ever. The highest point is right there at your vertex. So your vertex is 0, 1. Your maximum value is 1. And your axis of symmetry is x equals 0. What do you think? Not so hard? Always graph at least 5 points. I taught this lesson in high school last year, and I gave out the worksheet, and a lot of kids mix some things up. So what I would like to do right now is give you your homework that you can work on after your test, and do one of each kind together. All right? I think we're good there.